Alrighty. All right. So, folks, today we are going to be talking about graphing exponential functions using a table of values. All right. This is going to be a little weird at first. So, I'm going to give you a little bit of background knowledge before we jump into this so that we can get used to some of the stuff that you've seen in the past versus some of the new stuff. All right. So, let's talk about what an exponential equation looks like before we even jump into any of the other stuff, okay? So, let me drag this over here. So, just to start off here, an exponential equation, ooh, Lord, that's big. An exponential equation looks like this. Now, this exponential equation has a couple aspects to it. So, let's just label a couple of things before we go into actually graphing it, okay? So, first off, we got this letter here in the front, A. Let's just highlight that. Let's talk about what A actually is. Now, A here, I'm going to type this out, is the y-intercept. I'm going to go scale this down a bit. Yeah, this is, you got this from me last class. Do you need a copy of it? You don't need a copy? All right, cool. All right, so A is your y-intercept for the graph. Now, the other letter we got here is B. Let me go through and change up the color for our highlighting. All right, now B right here. B gives us a certain. It's kind of like the slope when you're looking at slope intercept form. B helps us generate certain parts of this. So let me go and type this out. So B is our multiplier. So both of these are going to come together to help us graph these. Now, this multiplier thing that I'm talking about with B, this helps us generate whatever the next point is, whatever the next point is, whatever the next point is as we go through this. Okay? Now, let's talk about how the graph actually looks like for these types of equations, because this is going to be kind of important for us to look at. Each of these graphs are going to kind of look like half a parabola in some way, or kind of like half a rational equation. So we got our x and y axis like we've been seeing before, and our graph is either going to come up real small and then start to curve up like this, or your graph will look like it started off real small near the axis and then start to curve down. So it'll look like one of these two things, okay? Any type of variation of these on the graph will show up as we do it, okay? All right, now, best way for you to go through and deal with this is using our calculator. You can, of course, graph these without the calculator, but if you wanted to check things, calculator is your best bet. So, you always got to use the y equals menu when we're doing this. Now, we're going to have some crazy exponents for our equations. So, if you had something like 2 to the x power, you will want to go through, put the base in as 2. Let me actually make this a little bigger for you guys to see. You would make the base be 2. Then you would have to use the caret symbol for any exponents that you have attached to it. And then if you're real cautionary, you could go through and put your exponent inside of parentheses. Now, if you got any expressions as part of your exponent, like if it was x plus 2, you would have to go through and make sure that that's inside of a parenthesis so it doesn't interact with anything outside of that and get goofed up possibly. You can also use more parentheses. More parentheses, the better, in case you're a little scared or whatever. Like if you wanted to put the base and the power inside of a parenthesis and then anything outside of it separately, you can do that too. Okay? So there's more than one way for you to deal with this. All right, so we're going to go through, do a little bit of graphing. I'm going to show you how some graphs look like for linear equations compared to how this is, and then I'm going to let you guys graph two of these on your own, okay? So let's take a look at some of the steps for us. Now, going through these graphs get either really small for your y values or really large. So the best place to start off for your x values are between -1 to +2. You can go from -2 to +2, but I'll warn you, there's going to be at least one really small value among these. Now, along these, you want to make sure that you use that caret symbol for any exponents when you type it in there. Use any parentheses when you have to deal with any expression parts or any negative parts for your exponent. And then keep in mind the shape that your graph should make. It should look like one of these two over here on the right side. Then if you need to check any of your points, you can use the table menu from the calculator. It's been a while since we used it. That's just second graph, and that'll pull up whatever the table is, all right? And then you could also look at the graph to just double check to see if your graph looked the way it should look, okay? So we're going to do 3 examples, and then you guys are going to try 2 of them on your own, all right? Now, let's go through, let's do a little brief example, and then I'm going to give you one more bit of information that you got to write in. All right, let's go through, let's get this. Our equation that we're going to mess with is y equals 2 to the x power. Let's get real simple with this. Now, we're going to go from -1 all the way up to +2. At least one of these is going to get a little too big for us. So don't freak out if you get a real big number. So when we're evaluating these, keep in mind the different exponent rules we've dealt with so far, okay? If you got a negative exponent, that's going to flip your stuff into a fraction. If you got a 0, that puts your stuff down to 1. And then anything else, you just got to go through and multiply that many times. So for -1, we got 2 to the negative first power. Remember, when you got a negative exponent, that makes it into a fraction. You take your base, that becomes your denominator, and then it's underneath 1. Because originally it was a whole number. We're taking the reciprocal, makes it 1/2. So for -1, its y value is 1/2, or if you look at it in the calculator, it's going to put it in decimal form. Decimal form, my fault, is 0.5. So, real small for this one. Next one we got 2 to the 0. Remember, anything to the 0 power other than 0 is 1. 0 is one of those trickier ones. We're not going to get into that, though. So, 2 to the 0 power is 1, which means that our y value for 0 is 1. Next, we got nice and simple. We got 2 to the first. We got 2 to the second. We've been done this. This is old school for us. That means that our two y values are 2 and 4. All right. Now, let's go through. Let's give the graph a chance to take a look at it, all right? So we got 4 x values we're messing with. We got -1. We got 1. And we got 2, and we got 0 right there on the origin. You can actually graph yours a little better. I can't see the graph too good on this side, okay? So these 4 red dots I'm finna make are our y values. 1, 2, 3. All right, so let's go through, give everything a chance to graph. We got -1 at 0.5, which is right above the x-axis right over here. Then we got 0, 1, which is our y-intercept. And then we got 1 and 2. And then we got 2 and 4. Oh, sorry. I actually did 1, 3, my bad. Let me fix that. 1, 2, and 2, 4. All right, so when we take this, here's our graph. It starts to curve up. Eventually, this is going to keep getting bigger and bigger as we go through and graph it. Now, to double check my graph, I'm going to go through and put it in the calculator. Okay? So we got 2 to the x power. Let me detach this. Let me make this a little smaller. All right, we got 2 to the x power over here. Okay? Hopefully that's big enough for some of y'all to see. My bad if it's not. We go through and graph it. There's our graph. All right, things that you might notice. You know on the left side how it's getting towards the x-axis, but it kind of looks like it stops. See, right over here, it may look like this is stopping there, but actually the y values for this are getting so small that you can't even see them really, okay? And this is going to make more sense when we look at the table. Now over here, on the right side, this going off the graph is because this graph is going up by a multiplier every single time. In this case, our multiplier for this equation was, oops, sorry, I meant to use the mouse, is 2. This means that this 2 here is showing us how big our y values are getting each time. If you actually look at all our y values, the next y value is the previous one multiplied by 2. Like if you took 0.5 times 2, that got you 1. 1 times 2 gets you 2. 2 times 2, 4. And you can keep going on like that to get all the y values. Really, if I give you just 1 point, you can kind of bust out the rest of them. Now, if we look at the table real quick, I'm actually blow this up real quick so you can see it. Right here from -1 to 2, those are the ones that we messed with. Now, if you go deeper into the negative side of the graph, these are the values for our y's that are getting so small that we couldn't see it on the graph anymore. See how small these are getting. It keeps getting smaller and smaller. And then around -10, you start seeing this E pop up. This is scientific notation. This means that this thing is so small, has like 4 zeros before you even get to the number for the decimal. Same thing for the next one. It keeps getting smaller and smaller and smaller. And it's going to keep getting down closer to 0, but it's not going to cross 0. You've seen something like this in the past. This is actually evidence of what we call an asymptote. This right here, this is showing us that these y values are coming towards a certain y value, but it's not crossing it. On the other end, though, for the positive side's just going to keep going up higher and higher. If you notice, each of these are multiplying by 2. See, we were here at 4. Multiply by 2, we got 8 for our y, then 16, 32, 64, 128, and it's keep going up higher and higher. Eventually on this side, we're going to also see scientific notation too, because it's going to keep getting bigger exponentially. Now, you don't have to go too hard in the paint for your graphs on these. I'm understanding that you're like me and you can't really be perfect all the time with this. So give me as much of a rough sketch as possible for these next couple ones that we're going to be doing, okay? All right. Before we do some more examples, let's just talk about asymptotes one more time as a review. Remember, asymptote, that's just an invisible line that we don't cross. These asymptotes are presented at whatever constant you might see for your graphs. You're not going to always see a constant value. So if you saw a constant, that's like us adding or subtracting a number to our exponential equation. So See in R1 that we have from our example, this is just y equals 2 to the x. There's no constant there. A constant would be something like plus 1. That would be the constant. And if you saw something like that, that would inform you that there's an asymptote at 1. If you don't see a number like this, that means that your asymptote is at 0, which is the x-axis. Now, these asymptotes, they're all horizontal. So there's going to be some horizontal line that we're not going to cross. And it's going to make sense as we look at whatever our graph is going to be. So, any questions before we do some more examples? Y'all feeling all right? All right, stop me if you need me to, okay? All right, we're going to hop onto the inside of this bad boy here. Make sure you keep your calculator handy because we're going to need that going forward. All right? Anybody still need what we got over here for the asymptote stuff? All right, go ahead and write that down. That's cool. I know. I probably would have written this down, but you see my handwriting in real life. It's not the greatest. Wanted to actually give you some stuff that you can really write down. All right. I'm going to slide this over to the inside of this. Madison, you got what you need? All right, all right. I'll let you copy that down. Now, one more thing at home, if you are going to be dealing with some of the exponents we are going to be dealing with, there's not going to be an exponent key that's going to put x up there. You have to visually put it with the symbol above the division key, okay? And use parentheses if you're feeling scared. Now, if you don't got a calculator, folks, you just got to go through and actually multiply it out like how we've done a million times up to this point, okay? It's just a chart. It's not going to give you any crazy values right now. That's why we're sticking close to the y-axis for our x's, okay? All right, let's hop on to the middle. We're going to be doing the top two just so I can show you the difference between some of the values that we're going to be dealing with, okay? So we got an exponential equation over here on the left side with 2 times x to the fourth. On the right side, we got a linear equation. It's been a minute since you've seen this, but we've done this. This will be easy, okay? So we're still going to be using the same values that we did on the front. So everything from -1 up to 2, those will be our x values. And then we're going to actually evaluate and calculate some stuff out. All right. We're going to do the top right one first because that's nice and easy for us. So I'm going to zoom in on that real quick. Let's get that done nice and easy. All right. This is nice and easy for us. This is just 9 times whatever x is. So you know what to do. We got 9 times -1. That's -9. We got 0 times 9. That's 0. We got 1 times 9. That's 9. And we got 2 times 9. That's 18. Now that's easy for us. We've done that before. We got 9x. Here's our graph. I'm going to just copy and paste that over on there because drawing this, it's a little much. Ooh, got a little too big there. Real big. Ooh. All right, things I want to caution you. See how our graph here, it's a line. I don't want you to get fooled into thinking that your exponential graphs are going to be a line. They may look linear at some point, but that's for the parts that's touching or getting close to the asymptote. All of our exponential equations are going to be curves, okay? It's not going to be like a parabola per se, but it's just going to be like, kind of look at it like a lowercase j, okay? It's kind of like that. You got one part that's a little smaller, dipping down, and then it's shooting up. So let's go through. Let's hit up some exponential stuff. Okay. I'm going to leave this over here on the right so that you got it. And let's deal with our stuff on the left. Alrighty. All right. On our left equation, we got 2 times 4 to the x. If you're calculating this, remember that exponent is just being attached to the 4. So that's the only thing that's being affected right now. So we got, first off, -1 for our exponent, which gives us 2 times 4 to the negative first power. Now, it might have been a while since you've dealt with to the negative power, and you might be a little confused with this. I don't want you to feel like you got to distribute anything. Once we're dealing with the evaluation portion of this, it's very PEMDAS in nature. Okay? Deal with your exponents, then deal with parentheses, then deal with any multiplication or addition after. All right? So we got 4 to the negative first power. If you remember that, that's going to go through and turn 4 into 1 over 4. And then 1 over 4 is going to have to multiply with 2. That means our final thing that we're going to have here is 2 over 4. This is also the same thing as 1/2, or inside of the calculator, it'll be 0.5. Okay? They don't really like putting fractions inside of the table part of this, so any fractions you get will be written as decimals. All right, next one, we got something popping off. We got 2 times 4 to the 0 power. Remember, I'm writing that exponent inside of our parenthesis just so we don't get confused and try to attach it to everything else, okay? So 4 to the 0 power, that's going to turn it into 1. So that's going to be 1 times 2, which is 2. Then we got 2 times 4 to the first. That's actually nice and easy. 4 to the first is 4. 2 times 4 is 8. Then we got 2 times 4 to the second. 4 to the second is 16. 16 times 2 gives us 32. See how big this stuff started to get, right? If you look at your equation, this informs us as to how it got so big. That 4 that we have inside of the parenthesis is what we're multiplying each of our y values by to get the next y value. See, if you take 0.5 times 4, that gets you 2. 4 times 2, that gets you 8. 4 times 8 gets you 32. Okay? And also from our equation, that number that was next to the parenthesis, that was our y-intercept. That's why we got this row right here for 0. Okay? Now, our graph, let's go through and take a look at it. Well, I got to turn my calculator on. That's wild to say I got to turn it on and it's on the computer. So make sure you type it out just like you see it. If you want to get more, particular about it so you don't mess up, just type your exponent inside of the parenthesis with the 4. So I'll do 2 times 4 to the x inside of the parenthesis, just in case I don't want to mess anything up. All right. So here's my graph. And it's curving up just like our previous one did. Okay. And since we don't have a constant attached to this, that same asymptote that we had from before is the same that we got right here. This is our, take that. No, I don't want to do that. That's a lot. I'll just use the snipping tool. My bad. Trying to just grab the graph so we can go and see it. Closing. Yes. No. Yeah. All right. Let's paste that bad boy. All right. So just like before, graph's starting to curve up, nice and smooth, like how it was previously. You might notice that your curve is happening a little earlier than it did the last time. That's because once we got around 2, it went all the way off the graph because, the graph is only 10 by 10. So by the time we got to 2, it's at 32. If we got to 3, it's at 64. Okay? Actually, might be bigger than that. My fault. Bad math on this. So remember, you don't got to go too far with your graphing because if you use your table, you're obviously going to see that there's not a lot that you can graph. If you're worried about graphing some of these points that are fractions, I'm looking for your best estimation, okay? I'm not looking for you to go too hard in the paint with it. I'm not looking for the most perfect, amazing graph ever. I'm looking for your best example, okay? So, you got yourself 2 examples of what it should look like and an example that it should not look like over here on the right. I want you to try these 2 on the bottom here, okay? Go through, calculate them out. Remember, we're still using the same x values, so -1 up to 2. So we can keep it nice and simple here. Once you got those all written up, give me a thumbs up in the air. I'll come over and check you out. For you guys at home, make sure that you go through and use your calculator to check it and check it with the online notes. Catch you later.